Morning, everybody. Again, it's Jason Crawford from Food and Beverage Ontario. I want to thank everybody for taking the time out of your busy day to join our webinar on the low carbon manufacturing. We've got Phil Dick from OMAFRA, Mina Hassan Ali from Provision, and Randy Clough from CCI. Phil's going to talk about cap and trade and zero waste from a regulations point of view. Mita is going to provide us an overview of the food loss and waste challenge, and Randy is going to discuss the opportunity to recover organic processing residuals. So what we'd like to do is you can type questions in as we go. If you can address those questions to whichever speaker you want to ask the question of, we'll answer that at the end of the webinar. If you, at the end of the webinar, if you want to ask any questions, we'll open it up for discussion. So. Again, the first part will be Phil from OMAFRA, then we'll go into Mina, and then Randy, and then we'll have some time for questions and answers. So I'm going to pass it over to Phil Dick from OMAFRA.
Good morning. I'd like to start with a brief summary of the things that I'm going to be talking about this morning. I'm going to touch on climate change. I'm going to touch on the Waste-Free Ontario Act that's up and coming, and I'm going to talk about some of the possible solutions as they apply to these two pieces of legislation. The first one is the Waste-Free Ontario Act is coming into effect in 2018. And when we look at what that is about, it's about managing organic waste and managing inorganic wastes. The MOE has identified more than 11 million tons of organics that they want to be able to manage. It's things that are going into our landfills, into private businesses, and being shipped across the border to Michigan and New York. The food industry's share of that, as far as we can estimate at this point in time, is somewhere around 4 megatons of organics. And that includes a large number of liquids. On the cap and trade side, I wanted to put up the picture of what the Environmental Commissioner is talking about as the emissions issue in Ontario. When we look at that and look at where the food industry straddles these things, for something that's 2% of industry, we've got a significant portion of organics, of electricity, largely because of refrigeration throughout the supply chain. According to the MTO, we've got about 18 or 20% of the road traffic, commercial road traffic, and we keep seeing coming out of StatsCan that there may be as much as 55 to 60% of agricultural production in Ontario is inside that supply chain. So the bottom line is the food industry has a supply chain carbon footprint that's much larger than the industry itself. That in itself is an opportunity. When we look at what cap and trade is going after currently, they are primarily looking at what is getting burned around fossil fuels. So when we look at the burn mix, we can very quickly identify where the overall target is going to be. It's in the barrels of oil, and it's in the natural gas, which is more than 80% of what the fuel mix is in Ontario, and it's when we look at 171 overall megatons, only about 6 megatons of that is coming out of the electricity matrix. Another picture, it's food for thought. It's around the carbon intensity of fuels. And this comes from a gentleman who was doing some work for the EU back in 2012, took a look at what the carbon intensity of electricity production was based on different fuel sources. When you look at the median for Ontario, which is nuclear, all of the renewables are significantly less carbon intensive. That's the opportunity. How do we switch to things like geothermal, solar PV, biomass, solar thermal, hydro, biogas, and wind? So on the cap and trade side, our food processors are looking at two basic methods of meeting cap and trade targets, which are about 20% reduction by 2020, 30% by 2030, 50% by 2050. The two ways that you do that are either you pay for offsets, which unregulated emitters pay for in their fuel costs, and those costs will be increasing over time. And you can go to the federal government, which has committed to an initial $10 a ton cost for carbon going up to as much as $50 a ton, which has been reported in the media. The other way to deal with cap and trade is to reduce emissions, targeting those things that get burned or create emissions. So we've got three categories of emitters in the food industry. We've got a handful that are above 25,000 tons. Those companies largely have cogeneration capacity. We've got a number that are over 10,000 tons, and those can opt in to be regulated. And under 10,000 tons, you're not regulated, and you just pay for cap and trade through the energy you purchase. So we've got a situation where there's either an energy burn or the ability to create an offset. And offsets, according to the regulation proposals that are on the MOE CC website right now, you've got until the 30th of December to give some comments to that. Those offsets have to be permanent. Permanent is defined as 100 years. Reductions can be monetized. You can get money for them, but you have got to be able to get past your target before those credits are worth anything. So you can't double dip by selling a 20% credit and then claiming that you're 20% lower. Those offset. So when we look at the food industry and the issue around developing credits, there are 5 major ways around fuel and energy management that we see that are opportunities. In transportation, fuel switching from diesel to renewable natural gas or compressed natural gas, it appears on some of the estimates right now that as little as a 5% solution of renewable natural gas in compressed natural gas will get you to a 20% reduction. For combustion sources, replacing renewable natural gas for natural gas, it may be as little as a 7% solution if you create your own RNG, or renewable natural gas. organic waste management by routing things away from landfill, away from land spreading, away from compost, maybe somewhere between 9/10 of a ton to 1.9 tons per ton of organics avoided. It's the same thing for the organics in your wastewater. And finally, waste heat recovery. We've identified in some food processors that have got intensive water heating systems and water cooling systems, as much as 30% of your input heating may be recoverable or may be at this point in time wasted. So number 1 and 2, that's an RNG addition. Number 3 and 4, they're sources of renewable natural gas. And it's the opportunity is, how do you make this work? And we'll be talking about some of these things. Later presenters will be mentioning some opportunities. Help getting there. It's really important when you go down the path of looking at developing a carbon credit and reducing that. You have to have an auditable trail. This is different than an energy audit. It means the accounting has got to be accurate. It starts with the baseline and a benchmark performance. Credits must follow a protocol where the people doing the accounting have to be different than the people doing the verification. And we've got a leg up here in Ontario with the Provision Coalition. They've got a portal where you can start to document. And it's not the only one, but it is a low-cost opportunity. And one of the things that was developed into the project at Provision long before this regulation came along. The other opportunity that's immediate is the Smart Green program. Has got $200,000 for a company as long as they're not regulated. Down the road, there's a renewable natural gas program that has been identified, and there's also been talk about a program for the regulated sector. Lastly, some contact information. If you want to talk to me directly, you email me. I'm happy to respond to any question. Thanks.
So now we'll pass it over to Mina from Provision.
Thank you, Jason. Thank you, Phil. Good morning, everyone. My presentation today will provide a background context on food loss and waste challenge in Canada and focus on the business case for reducing it, highlighting a number of projects that we're working on with the industry. Provision is a coalition of 12 industry associations across the food and beverage manufacturing sector, as you can see. Now, food waste is a key component of organic waste, and our members have identified food waste as a key priority for our industry, and so we're working along with our members and food and beverage companies to address this issue in Canada. Now, in 2013, we commissioned a research project with the Network for Business Sustainability, Ivy Business School, and Value Chain Management International to map out the food waste challenge in Ontario and Canada's agri-food industry to really understand how big is the problem, where is it occurring, and how can we tackle this issue. It is estimated that 30 to 40% of food produced is lost along the value chain, with much of it finding its way to landfill or composting. This food is worth $31 billion each year. In fact, according to the researchers, this is a conservative number, especially when you take some of the energy and water and labor that went into making that food. That cost would actually be closer to about $100 billion a year. What these numbers are suggesting is that there are significant business opportunities for our industry and along the value chain to come together to optimize operations, reduce costs, reduce the overall footprint, and better manage risks, which could be regulatory, as we heard from Phil, or business risks in reducing food waste. Now, when it comes to definition of food loss and waste, they really vary. The researchers found that in Canada, there is no commonly agreed upon definition. There are concepts like waste, loss, yield that are lumped together. Food waste and organic waste are used interchangeably. It's not clear whether, how do you distinguish between what's edible versus inedible? What's edible in one part of the world may not be edible in other part of the world. And so there's all these sort of questions when it comes to what is the definition of food loss and waste. Since then, there has been some movement in this space. The Food Loss and Waste Protocol is a multi-stakeholder effort to develop a global food loss and waste standard in quantifying and reporting on food and or its associated inedible parts removed from the supply chain. We've all heard this before. What gets measured then gets managed. And so in this standard, food is defined as any substance, whether processed, semi-processed, or raw, that is intended for human consumption, includes drink and any substance that has been used in the manufacture, preparation, or treatment of food, and it includes material that has spoiled and is therefore no longer fit for human consumption. Now, why does food loss and waste matter? Globally, we're seeing very similar figures out of the World Resources Institute. A third of all food is lost or wasted each year, and that is costing the global economy about $940 billion each year. And that 8% of the annual global greenhouse gas emissions are due to food loss and waste. If food loss and waste was its own country, it would be the third largest emitter after China and USA, and that each ton of food waste emits about 1.9 tons of equivalent CO2 across the food supply chain. So the correlation between climate change and food loss and waste is loud and clear. And then there are other factors which businesses do recognize in reducing food waste and realizing the true cost of food waste extends far beyond just the disposal fees. And it includes the cost of raw materials, plus all the value-added materials that went into making that food, the cost of water, energy, and labor, etc. Now, while manufacturers are operating within slim margins, reducing your waste and reducing your costs can mean a difference between operating in profit and sort of loss margins. Now, how a business manages its food waste can send a strong message to consumers, and especially in an era where consumers are demanding all kinds of transparency information in terms of what's in my food, how is it being made, and what are the impacts resulting from the operations. And so what we find is that businesses that do have a corporate sustainability mandate view it as an important issue to tackle and manage. As you can see in this next slide, it is a complex issue affecting our entire supply chain, from farm to food processing to distribution, to retail, grocery stores, food service organizations, restaurants, and of course, consumers. Now, the next slide here shows the distribution of food waste throughout the value chain. Consumers are by far the largest contributor of food waste. As you can see, the big red 47%, and then the processing and the packaging sectors contributing about 20% of this food waste. So Provision Coalition is taking a multi-stakeholder collaborative approach to tackle this issue. We've commissioned 2 groups, a food waste working group, which consists of food and beverage manufacturers and solution providers, as well as food waste collaborative members across the value chain, really coming together to identify opportunities, pragmatic solutions, and best practices to decrease the amount of food waste being sent to landfills from our sector. We are focusing our research on what are those innovative, practical, technological opportunities that are available, readily available in the marketplace, and some industry best practices. And while source reduction is definitely a top priority or should be a top priority for business, there are options available once the food waste has been generated. And so today we'll be hearing about one of that option in the webinar from Randy. I just wanted to put a shout out for an event that we're planning, Canada's 2017 Food Loss and Waste Forum. The theme for this event will be, again, finding solutions, and all the research that we're doing on looking at some of those best practices and technologies will be tabled at this event, so please do mark your calendar. I also wanted to show you a live food waste reduction toolkit that's now available in our portal or the sustainability management system. This was really put together with all the collaborative efforts of our working group and solution providers who developed the content. And what this tool provides is really helping manufacturers quantify their food loss and waste, calculate its true value, and more importantly, explore the root causes of this waste and identify solutions that can be implemented at a manufacturing level. This toolkit is live and available to all the food and beverage manufacturers through our online sustainability management system or the portal, and I'd be happy to connect any manufacturers online who want access to the portal. Now we're working with companies across our sector in piloting the toolkit, and these are companies who are working on the toolkit right now. And I wanted to give an example of a pilot with the Campbell Company of Canada, where a conventional 3 R's audit only touched upon 1% of its food waste. We're working with them along with a third-party consultant who's conducting a comprehensive food waste audit to look at some of the root causes and solutions that can be applied within Campbell. Even though this sort of study is early in its stages, it has been estimated about $300,000 in savings from implementing various food waste management solutions. The case study for this will be available in spring of 2017, so we look forward to publishing that as well. I also wanted to share with you another project that we're working on with Ippolito Group and PNP Optica, along with other collaborators, to pilot and test an application of a chemical imaging technology that is being applied in the food processing setting. Ippolito has identified food waste as its sort of top priority, and PNP Optica, which is a Waterloo-based technology company, has developed a chemical imaging technology that uses optics, chemistry, and physics to assist the facility in analyzing spinach quality, and can detect bad versus good spinach in a very cost-efficient manner. And what we're hoping for is that this pilot will determine whether this particular technology can reduce the facility's food waste by 50%. There is more information about this particular pilot on our website through a food waste video production. It's also available through Provision's YouTube channel if you'd want to check it out. And this is who we are. Thank you so much, and I'm going to pass it on to Randy.
Good morning, everybody, and thank you for joining us today. We appreciate that, and thank you both to Mina and Phil for excellent presentations. I wanted to speak to you today about something focused to solutions that we can look to deliver in the food and beverage industry after we've reduced the amount of waste that we produce. A little bit about our company, CCI Bioenergy. We have an exclusive license to a large-scale anaerobic digestion technology known as the BTA process. Some of you that live in the Toronto area would be somewhat familiar with that in terms of your green bin waste in Toronto goes to facilities that use the BTA process. And since 2001 and last week, we reached a milestone where we have now converted more than 800,000 metric tons of organic waste here in the province of Ontario into energy. The focus of what we really want to talk about here in a solution perspective is the next point about being a registered installer of a cube renewable system. And this is a small-scale, on-site distributed energy solution whereby you can take your organics, keep them on site, and produce energy for your own use. And this is a real paradigm shift in the industry. It's certainly a change of thinking. We're used to taking our organic materials and wastes and sending them off-site. This is a shift in that. It's also going to disrupt the supply chain. When you think about traditional waste movement today, where we put it on a truck, send it to a landfill often, we eliminate that part of the supply chain within the waste management infrastructure as well. So climate change, there's really a couple key drivers. Both Mina and Phil have touched on these earlier, but I just wanted to review them once again, and that's climate change mitigation. Certainly we've got the new Climate Change Act here in Ontario, which we're part of the Western Climate Initiative, passed in June of 2016. That program is expected to generate about $8 billion over the next 4 years towards delivering a low-carbon economy in Ontario, and the intention is to reinvest those monies back into GHG reduction solutions. And the last component of that is some new draft offsets regulations. Phil had mentioned these earlier, but on November 15th there was an Environmental Bill of Rights posting with respect to the offsets and how that's going to work. And Phil had mentioned earlier, the organic waste in our system here in Ontario is up to a 4 megaton reduction opportunity in our carbon footprint. That's across the farm to fork value chain. And certainly we've heard that a focus is to creating alternative fuels to help with those offsets. And we see, and it's been consistent in various data and research that's been done and expectations that have been set, that you can have up to a 2 carbon credit 2 tons offsets per 1 ton of input into systems such as a micro AD solution. The other component that's driving change is the Ontario Waste-Free Ontario Act, and really this is saying your organics are assets. If you can recover them and not waste them, you can deliver some diversion achievement and deliver reductions in your carbon footprint. This is another act that was passed in the summer of this year, and there will be new instruments to divert organics. And we certainly are proponents of the fact that you want to reduce the amount of waste that you produce first before you start to take the remainder of it and convert it into some other high-value product. This is an important component here. Interestingly, on the 23rd of September, 2 months ago, the MOECC mandate letter specifically states that the Minister of Environment will develop an organic action plan in 2017 with implementation in the spring of 2018. And so this is something that's coming at us quick, and it's going to be focused to the industrial, commercial, institutional sector to pick up on the diversion achievements, which are pretty low in today's world. And I think what's important to understand is that we're going to see some new tools in Ontario that are going to help to divert organics. We're seeing tools in Quebec, in British Columbia, and in a lot of the northeastern states whereby organic materials are going to be banned from landfilling, and we're going to also potentially see clip levels in terms of the amount of organics that you may generate and the requirement for you to divert those. We know that in places like the Northeast U.S. and Quebec, they've started out in diversion plans whereby if you're producing more than one organic ton of waste per week, that you are required to divert that material. So we'll see what comes here in Ontario, but certainly it'll be very similar tools that are aligned to drive diversion of organics. So at the end of the day, you really take those two components. We've got a sort of a near zero waste driver. We've got the neutral or negative carbon footprint driver, and ultimately what we're talking about here with a microscale system is the opportunity to mine the surface gas field or to recycle the atmospheric carbon. And those are the opportunities, and that's how we're going to build this value that comes to both our societies and to all of us that are generating carbon. So how does this translate? You've really got two opportunities in taking your wasted organics and the impacts that they can have in our businesses. The first option, as Phil had mentioned, was to create a renewable natural gas, and that can take two forms. By cleaning up the biogas, you can create a pipeline-grade biomethane that can go into the pipeline, or it can go back into your own internal system to offset your natural gas production. You can take it one step further and compress that renewable natural gas, and then you've got a transportation fuel that you can run trucks and other vehicles with. The other option is to use the biogas to create combined heat and power. Certainly some of you have cogens on site today. In cases where you don't, we provide small cogen units that can create electricity, again, for internal consumption, and you can use the heat to create hot water for your own internal needs. So what can we put in the system? Well, it's really a broad range. If it's organic, you can put it in. That's a general statement, with the exception being wood material. Wood does not break down in a digestion system. So in your case, there's lots of processing residuals that occur throughout the supply chain. They can be, let's call them more solid type materials, such as trimmings and things from lettuce, etc. Or we have more organic, liquidy type materials. It could be juices, spent beverages, those sorts of things. And we would also include any fats, oils, and greases in that organic liquid residual. We've also got some sludges and filtrates from DAF systems, from wastewater treatment facilities on site. There's organic materials in there that Phil had mentioned as well that can be used to create energy on site for your own purposes as well. The other component is the depackaging side, whether you have damage, spoilage, off-spec materials, these sorts of things. Those are all organic materials that can be captured and recovered and used to create energy on site for your own needs. The solution specifically is called the Cube Distributed Energy System, and as I said, it's based on anaerobic digestion in the absence of oxygen. I think everybody's familiar with that. These systems, there's a couple of pictures there. The bottom left is the containerized configuration of the digestion system. The right side is the flexible fabric digester design. These systems will range in a capacity from 1 ton a day to 10 tons a day of daily input, or 350 to 3,500 tons annually. Certainly all the components are scaled down or miniaturized, and that's quite frankly been one of the barriers to scaling down anaerobic digestion systems. It's not been the size of the digesters and components themselves, it's been the utilization systems. Cogeneration systems have usually been measured in hundreds of megawatts. Biogas cleaning systems are also very large scale, multiple millions, but we've seen some evolution now in technologies whereby you can implement cogen systems that are down in the 3.5, 5, 10, 20, under 50 kilowatt systems, and we've certainly seen the development of gas cleaning and renewable natural gas systems that are scaled down as well, so it makes it economically viable in a smaller footprint like this. There are some videos, and we will pass around these presentations after, and there are some videos online that you'll be able to click on to see these systems both in action, and also some time-lapse photography of how quick they are to implement and install. We're talking about in a day's time, plug and play, away you go to start feeding the system. How does it work? Fairly straightforward. We've got our inputs there on the left-hand side, so you can see whether you're in any part of the supply chain. The bottom line is where there's people, there's food. On a post-consumer basis and on a pre-consumer basis, obviously, the waste materials that all you folks are generating out of the back ends of your facilities. Manures and sewage are also components that can be fed into the system, as are specialty crops. The idea here is pretty simple up front, to macerate the material to make it uniform, kind of going back to, as our mothers told us, chew your food 32 times. It's certainly important for good digestion. The material is then loaded into the digester. It's kept at a constant temperature, so we use any heat that's required, especially in the winter times, to keep that at a constant temperature, and there's heating coils inside the system. The biogas is produced on a continuous 24/7 basis, and when that gas comes out, we then put it in whatever energy unit is applicable to the solution being delivered, and consumption then can occur internally to offset your own energy needs. So fairly straightforward. The idea of creating renewable natural gas, certainly we've heard a lot about that today, and I think if you look at the right-hand side of this slide and where we see the underlines there, this is an actual cutout of the Climate Action Plan in Ontario and how we're going to be focused to establishing low carbon content in natural gas. And as you can see by those underlines there, and there is a focus to the entire farm to fork supply chain to be sources of these materials. So we believe, and these numbers vary across Canada and who is calculating them, but there's a lot of work being done on that, but certainly biogas is a source to create renewable natural gas, and it is estimated that across Canada up to 10% of our current supply mix could be replaced with renewable natural gas. There is a focus, as it's shown in the Climate Action Plan, to the food and beverage sources, and certainly that's across the entire value chain, so there's lots of organic materials that exist from the farm to the fork, and those can be used to create energy. And that energy, as we talked about earlier, can take two forms. So if we want to clean up the biogas, we can create renewable natural gas to put in the pipeline, or we can compress it for vehicles. The rough equivalent, if you were to compress it to vehicles, is that for every cubic meter of biogas that's produced, it's the equivalent of about 0.75 liters of gasoline. And that's significant when you start to look at certain materials. Every material has a different biogas profile. Some can be upwards in the area of 150 cubic meters per ton. Things like fats, oils, and greases can be up in the 600 plus cubic meters per ton. So as you can see with some rough math, there's a lot of potential fuel that can be produced from those wasted organic assets. The other option is to use it as an alternative fuel in combined heat and power. That could be in a current cogeneration system that you have installed or one that you're planning to install. It could also be in a cogeneration system that's supplied with the system. We'll probably always supply a small cogen with the system just to be energy self-sufficient in the heat and electricity that it requires to operate. But then again, there's some flexibilities depending on your internal infrastructures. These systems could be linked in to share energy and heat across both systems. We want to take the heat and create hot water. Just to give you a relative reference, 1 cubic meter of biogas will create the equivalent in the small cogeneration world of about 2 kilowatt hours of electrical and about 2.7 kilowatt hours of thermal. So that's in the world of cogen, but interestingly, you can also use biogas to fuel boilers. Certainly, whether those are boilers that might be dual fueled that can run directly on either natural gas or biogas with little or no treatment, or natural gas fueled boilers whereby we would clean up the biogas to create a renewable natural gas to power those boilers. In any scenario, it's certainly a potential source of fuel that you can again create from your wasted organics to put power back into your facility. So that's an overview of the system, the solution, and the components, and where are we at right now with developing this solution and technology. We have a food processing demonstration project that will kick off in January. And the objective here is to really show the way for the opportunity that this has and the solution that it can deliver in the food and beverage industry, and obviously as well to iron out any wrinkles. We've been in the business for over 20 years, and we understand that, you know, every good plan will have humps and bumps, and so we are going to use this demonstration opportunity to learn about what those are and to solve any of them that we may come across. So first phase will kick off in January of 2017. We will make a formal announcement in January about this project, so stay tuned for that, and certainly part and parcel of all that will be, once we get it operating, is to provide tours of the facility. But the first phase, we will install 2 of those containerized digesters that you saw on the earlier picture. CCI is supplying those. And the idea, well, along with other components, cogen and a macerator, and all covered in a coverall fabric type building. And we'll look to prove out the components and prove out the business case models that we have. The second phase of the system, we'll see those 2 containerized systems move on and move out to other locations, and we will install the fabric style digester in its place, and at that time that'll increase the volume of materials that the food processing company that this is installed at will be generating. We'll add some other different materials into the system, and at that point in time we will add the transportation fuel system to the demonstration project. As you can see, we've got partners in this. Toromont is certainly a partner. They're a large dealer for Caterpillar cogenerations in much of the northeast U.S. and eastern Canada. Enbridge will also be part of the demonstration, and we've got some educational component here to do some research, some monitoring and things, and that will be delivered by York University along with some funding from the MyTax organization. And then that'll leave us to the next summer and summer of 2017 coming up. And this is where there could be an opportunity for others in the food and beverage industry. We will be looking to take those 2 machines and put them back out into differing food and beverage than industries and differing materials than this first one is. And that certainly could open up some opportunities for folks to be able to take advantage of understanding how it fits into their business. And there's also some funding opportunities that are available to do this and or to acquire systems for your own use. And those funding opportunities, some exist today, and there will be others rolling out over the course of the next 2 to 6 months. So just a next question, famous question, how much? So this is an attempt here, as you can appreciate, with the number of variables and things that there are. This is a little bit difficult because each scenario is different, but let's run through this pretty quickly. Across the top, you see the input capacity. So we've run a model here for 1 ton a day, 2.5 tons a day, and then to the right, the 10 tons a day. So you can see how that calculates out on a per year basis. So the first thing we have to do is make a choice between either utilizing the biogas as CHP or as RNG. So it's one or the other. The business case here, we've used a straight 15 cents a kilowatt hour on the electrical thermal side, and we used $1 for liters equivalent. So as I said, it's one or the other. It's not both. And hence, when you see bullet or point number 1 about the energy cost displaced, that's the first element of the business case, and the range is given because the choice would be either on the low end side, the CHP, or on the higher end side, the compressed renewable natural gas. So on a 1 ton basis, we see $35,000 to $50,000 a year, and you can read over from left to right to see the potential value in energy production that can come from those size systems. Then to that we add the current contribution and cost that you have with your current waste disposal systems today. Those don't go away, but those dollars would get redirected towards paying for the capital and operating cost of the system. That's a difficult one to state because certainly everyone's values are different, but we've seen numbers that range anywhere from $100 to some cases over $200 per ton. And that's a difficult calculation because your service provider often doesn't provide those services on a per ton basis, but more or less on a per pickup or per lift basis. The third component that's part of the business case is the upside revenue potentials that come. Certainly, we've heard about the carbon offsets revenue potentials. That's to be determined. We've heard lots of different numbers between $15 and $50 per ton of carbon to be determined, but the point is there certainly could be some benefit there. For those that are capped, there's some benefit in terms of being able to reduce your requirements, so there's still an economic value to that. We're also going to look at the liquids that come out of the digester and see what kind of fertilizer property values they have, so there could be some economic benefit there. And we also are hearing about renewable fuel standard type approaches here in Ontario that could also add some potential revenues to the business case in terms of the selling off of those environmental attributes. So when we take all three of those components and add them together, and then use our three examples of 1, 2.5, and 10 tons. On a simple payback basis, there's a range again there. And that range on the lower end side, and payback is the CRNG option. On the longer payback, it's the combined heat and power option. But as you can see, simple paybacks. There's some scaling here as well. Smaller scale systems, 1 ton. We see a 4.5 to 6 year payback. On the mid-size 2.5 tons, 3.5 to 5, and when you get into the larger scale systems, we're seeing a 2.5 to 4 year payback on our business models. And the interesting thing to note here is that these business case elements do not consider any funding or grant opportunities that may come, which will help to make the payback smaller, and certainly any other soft benefits or costs that you may have in your business around corporate social responsibility and things have not been factored into the equation. But that should give you some sense of the kind of scaling, economies of scale, and the kind of components that are required to build the business case. My final slide is just to present to you some opportunities that are out there today. Certainly we're going to see more and more programs coming out from various Ontario ministries over the next 6 months or so. So we all watch for those. Those are certainly to be determined. And we have some current programs that exist today. There's something called the Target GHT program out of the Ontario Centres of Excellence. And that has some linkages to Sustainable Technology Canada. There's also the Smart Green Fund, which Phil had mentioned earlier. That's available now, and it's continuous intake, up to $200,000. There was an announcement made last spring, and it was re-announced here in October, but not many details yet. But there will be a Natural Gas Innovation Fund coming shortly, which is another opportunity to look at funding these systems. And there is the Atmospheric Fund. This is more on the financing side. You may be familiar with it as the Toronto Atmospheric Fund. The name has recently changed, and that change, one of the reasons was because of the broader mandate and scope. They're not just focused specifically to the city of Toronto or the GTA. So we have the opportunity there to deliver funding packages for the capital and operating, whereby the payback from revenues generated and disposal costs would go to the Atmospheric Fund until the system's paid for. Then all those dollars would flow back to the user. So that's some of the funding opportunities. And we're finished. And if you've got any questions, we'll certainly look to entertain those. Thank you all very much.
Thanks, Randy, for the presentation. Any questions from anybody? No? Okay. Well, again, thank you for attending the webinar. We are going to be sending links out to the slides as well as the video. And with everybody's contact information, we'll also be posting it on our website. So again, if you have any questions, please don't hesitate to contact any one of the presenters. Great. So thanks very much, everybody, and enjoy your week.
Hi, it's Randy. I understand there's a question here about York's role. York's going to provide some grad students and things, and so they're going to be doing some work around inputs, biogas production, and volumes and yields, and also some work on the back end in terms of the kinds of products that are produced and their attributes. There's a question here about is a sole project or could I get in touch with them? To the person that's asking this question, I would ask you to get in touch with me directly, and I can lead you to some of the folks that we've been talking to at York. And it's Randy Clough, and you can reach out to me on my cell at area code 519-502-3747. No more?